All right, we are moving on to chapter 7, and we are starting the second part of chapter 7, section 1, which is composition of functions. So what we're going to do is review chapter 7, part 1, which was plugging in values of a function. So f of negative 3 came from plugging in negative 3 to f and getting negative 6. And then g of 6 came from plugging in 6 to g. And that gave us 6 plus 1, which was 7. So we are on operations of functions day 2. Our objective is to find composite functions or function composition. So the first thing we're going to look at is if you have h of x equal to 2x plus 7, how can I rewrite an equation for h of 3x? So what you're going to do is take 3x and plug it in. So 3x is a function. So we're going to plug that function into another function. So you're going to plug 3x in everywhere you have an x. So you get 2 times 3x plus 7. Which becomes 6x plus 7. We can do the same kind of idea if there's a number in front of h. So you have 3h of x. So what you're going to do is multiply the entire function by 3. So that gives 6x plus 21 because you're going to distribute the 3 to both terms. And then we could also do the same thing with the number 4. So you have 4, you're going to distribute to 2x and 7. So you get 8x plus 28. Okay. So composite functions basically represent the substitution of one function into another. We have the rule that basically if you have f and g, that the range of g is the domain of f, and then the composite function f of g of x is equal to f of g of x. So we don't call it fog. It's not fog. It's f of g. So let's look at examples where we have f of x equals x squared minus 3x plus 1 and g of x equals 2x minus 3. We want to find both fog and goff. So what we're going to do is remember f of g of x equals f of g of x plugged in, which is the same as saying f of 2x minus 3. So now this is a lot like our examples at the beginning. So what we're going to do is everywhere x was on f, we're going to replace it with 2x minus 3. And then we're just going to use algebra to clean this up. So if you have a binomial squared, you have to use FOIL. So that's like 2x minus 3 times 2x minus 3. So you get first, outer, inner, and last. Combine like terms in the middle. And then bring it back. Okay, so we took what we FOILed, brought it over. Now we're going to distribute the negative 3. Carry the positive 1. Combine like terms. And 4x squared minus 18x plus 19 represents f of g of x. So now we can do something similar, but we can look at g of f of x. So now that means everywhere g has an x, we're going to replace it with x squared minus 3x plus 1. So that becomes 2. X squared minus 3x plus 1 minus 3. We have to distribute our 2. Combine like terms. And we get 2x squared minus 6x minus 1. Now what you'll notice is f of g of x and g of f of x are not the same. That is okay. They usually are not. All right, let's look at another example. So we want to find f of h of x and h of f of x. Sorry about that. Those g's should be h's, or you have to make this h a g. Both will work. So f of h of x means that everywhere f has an x, we're going to replace it with h. So that's kind of like saying f of the cube root of 2x minus 15, which is like saying the cube root of 2x minus 15 cubed minus 6. But the cube root and a cube cancel, so you get left with 2x minus 15 minus 6. Combine like terms, and we get 2x minus 21. We can do something similar for h of f. So h of f of x is equal to h of x cubed minus 6 So everywhere h has an x, we're going to replace it with x cubed minus 6. So that becomes the cube root of 2x cubed minus 6 minus 15. So then you get the cube root of 2x cubed minus 12 minus 15. Combine the 12 and the 15, and you get the cube root of 2x cubed minus 27. You can't simplify a cube root that has something being added or subtracted. So even though the cube root of 27 is a nice number, you have to leave it like one mass quantity. All right, now we're going to look at finding the function composition using numbers. So last two examples used variables. Now we're going to do the same thing using numbers. I actually think numbers are easier. So what we're going to do is start on the inside and work our way out. So what that means is we're going to start with g of negative 2. So we're going to find g of negative 2. So g of negative 2 would be negative 2 times negative 2 plus 3. So you get negative times a negative is a positive 4. 4 plus 3 is 7. So really this is like saying find f, and instead of g of negative 2, you replace it with 7. So it's like saying, okay, find f of 7. So f of 7 do not know what's wrong with this pointer today, is equal to 7 squared So again, this is like finding f of 7. So then f of 7 says that we need to plug 7 in. All right, so f of 7 is equal to 7 squared plus 2 times 7 plus 1. So it's 49 plus 14 plus 1. So that's 50 plus 14, which is 64. So f of g of negative 2 is equal to 64. We can do the same thing for other functions. So we can do it with h of f of 3. So first we find f of 3, which is 3 squared plus 2 times 3 plus 1. So you get 6 plus 9 plus 1. So you get 16. And then that's really like saying h of 16. So we're going to plug 16 into h. So you get 4 times 16, which is also 64. And then this is really like g of h of negative 1. So you're going to find h of negative 1 first. So that is like 4 times negative 1, which is negative 4. So this becomes g of negative 4. And g of negative 4 is negative 2 times negative 4 plus 3. So you get 8 plus 3, which is 11. So g of h of negative 1 is equal to 11. Example 4. For each pairs, find both f of g of x and g of f of x if they exist. So basically, in order to find this, so f of g of x is saying, okay, we're going to take g, so g of 3 is equal to -9. Then you go up to f and you look for -9 in the domain. That does not exist, therefore that point does not exist. So g of 7 is equal to 2. There is no f of 2, so that point does not exist. G of 8 is equal to -6. No -6, so that does not exist. G of 12 is equal to 0. No 0. So f of g of x is an empty set or undefined. So it does not exist. G of f of x says that you go to f of x, so we have -15, -5, and then find a -5 here. Doesn't happen. -4 goes to 12. Find a 12 down here. It maps to 0. So g of f of x at -4 is 0. 1, 7, 7, 2. So we have the point 1, 2. 3, 9. No 9. Doesn't exist. Let's try this again with a different problem, because those are a little tricky. So f of g of x. So again, what we're doing is we're starting here and going to -4. So then you look for a -4 up here. Doesn't exist. 4 maps to -3. Look for a -3. Doesn't exist. -1 maps to 2. 2 maps to -2. So -1 maps to -2 because they match. 2 maps to 3. No 3. Does not exist. So f of g of x only lives at one point, and that one point is -1, -2. Let's look at g of f of x. So -1 maps to 11. No 11. Doesn't exist. 2 maps to -2. No -2. 5 to -7. 4 to -4. Therefore, this is undefined. All right, and that is function composition. We will be reviewing that for the next 4 days. Thank you.